is for the attendance. So let's continue with this one. All right, so for the address, direct addressing mode, so actually, the address field that we have is actually the address of operand in memory. Okay, so example, if you add A, so look in memory at location, with an address A for operand value. Right, add content of word A to AC and store the result back to AC. Okay, so example here is AC come from AC plus memory of forward A here, yeah, in the memory. Okay. Okay, so this is how it add lah. Memory forward A just now. Okay, because in memory in this is M, and then this is forward A, and then plus the AC, and then the AC, the value for AC is come from AC plus ME. Okay, advantage of the direct address mode here is one memory reference to access data. Okay, so number 2 is no additional calculation to work out to get an effective address. So this is the advantages of using the direct addressing mode. Okay, but there is disadvantages. Limited address space, the length of address field is less than the word length. And then look into this format. Okay, we have the opcode and then the instruction. That, for example, we have A instruction, and then in the memory actually, the A here is with the operand value. Okay, A here with the operand value. So so here lah, M of A here actually put into the operand value in the memory of A here. Okay. And then the next addressing mode is indirect, so meaning that not using directly the memory place. Okay, the address field that we are referring here is address of a memory word that contain the actual address of an operand. Okay, example, we have the expression add A here. Look in memory at location of word with address A. Okay, the actual address of an operand is in this word. Assume that the value in word A equal B. Okay, A here will equal with B. Add contents of word B to AC and store the result back to AC. Okay, so how AC here is get is actually from AC plus the memory, and inside the memory there is A. Okay, whereby this one is actually memory of B. So actually the AC here is plus the memory of B. Okay, the memory of value B. So it will add the contents of word B to AC and store the result back to the AC. So this is the first step, and then the second step. So AC here will equal AC plus memory of B. Memory of word B, sorry. Okay, the actual address of an operand is in this word, okay, because it used the word in the memory. Assume that the value of word A here equal with B. So the value. Okay, so we look into the advantage. It has bigger address space compared with direct addressing mode. But the disadvantage here is multiple memory access to find operands. hence lower access time. Okay, because there is multiple memory access to find operands. Yeah, first is we look into the A first, the A place, and then after that it look into the operand of B. Okay, the operand of B, the operand value of B. So this is the disadvantage of this indirect. So meaning that it's not used direct addressing mode, indirectly. So if indirect, so of course slower access time because there's too many places to look into. Okay, so this is indirect addressing mode. And then another type for addressing mode is register direct. So register direct is actually, all right, in this format, the operand is held in a register name in address field. So you have the operand held in a register and then name in address field. So this is the register address. Okay, after the opcode, there is the register address. So advantage of this method, register direct addressing mode, is actually small address field is needed. Okay, no memory references are required. It requires fast execution. Okay, disadvantage here is very limited address space. Okay, so look into this example with add R. Okay, you want to make addition for R using the register direct addressing mode. So you need to have two field only. First is opcode and another one register address. Okay, so add R here will first you need to do the operand value is in a register. And then you need to add content of register R to AC and store result back to AC. Okay, so the AC here will equal AC plus the R. Okay, AC plus R. So here actually how it works in the memory and the instruction. So register address R here. So actually it look into the registers. Yeah, where is registers? Do you know where is registers? Where is the location for registers? In the processor, in the CPU. Okay, so in the processor, if in this one, for the indirect addressing mode, so meaning that it will use the memory. Okay, same as direct addressing mode, also it will use the memory. And then with the immediate addressing mode, it will not use the memory to fetch data. Okay, so it use the accumulator inside the CPU, inside the processor. So itulah bila when you use the direct register direct addressing mode, so meaning that you use the registers, yeah, registers inside the processor. So so this is how slides. But anyway, you look how the architecture for direct register addressing mode here. This is the direct, right? So direct basically will use the registers, but for the indirect register, so basically you use another one. R here will point to the registers, okay, for the operand B, but it will refer back to the memory to look into the value. So this one is called the register indirect addressing mode. Okay, so when you have this one, so actually this one inside the processor and also the memory, it look into this one. Okay, you find the pointer to operand B, and then the pointer will point into the memory, the value for the operand. Okay, the value for the operand. So in the instruction, you just look into the register address for R. Okay, register for address for R. Okay, so this register indirect addressing mode actually is analogous to indirect addressing. So address field refers to a register. Operand value is in a memory word or location pointed by a content of a register. So advantage here is bigger address space, same as indirect addressing, right? But disadvantage here is multiple memory accesses to find operand, hence slower access time but faster than indirect addressing. Okay. So this is how the register direct addressing mode and indirect addressing mode actually explained to us. Okay. All right. So we look into the displacement of addressing mode. So combine the capabilities of direct addressing and register indirect addressing. So it's known by a variety of names depending on the context of its use. So requires that the instruction has two address field. Address field hold two values, right? A here is a base value. R here is a register that holds displacement or vice versa. So the effective address that we have A plus the R. Okay, R here is actually the register that hold the displacement. Okay, so let's look into this one. So we use the add R, for example, add R here, add A or add R, add R, okay. Okay, so the instruction here has the opcode and then register R and also address A. Okay. So when you use the displacement addressing mode, in the format, it has the opcode register R and actually another place to in the instruction format is address for the A. Okay, any value A here. For example, you use A. So A here actually look into the operation to have between when the register R is pointer to operand, okay, and then the operand will look into the address A that you have, okay. For example, add A, add here, okay, add here, and the opcode is R add, okay. And then what is the operand that it refers to? So this is the displacement of addressing mode. Effective address A plus R. Mm. Okay, so displacement addressing will continue. Common uses of this displacement addressing. So it has the relative addressing. For example, R here is a program counter. All right. So EA here is actually A plus PC. So example, or in other words, plain get operands from cell A, all right, from current location pointed by PC. Okay, so this is the relative addressing. And then let's look into the base register addressing. A holds displacement. Okay, base register addressing. A holds displacement, R holds pointer to base address. R may be explicit or implicit. Either you can see or maybe you want to hide. Example, segment registers in 80 times 6. Okay, this is used in 80x86 register segmentation. Okay, and then the next one is the displacement addressing, also used for index addressing. Index addressing is A equal base, all right? R is displacement. So EA here is A plus R. Okay, so the index addressing actually good for accessing array. Okay, EA equal A plus R, R plus plus plus. Okay, so it is basically you want to access the array, or you want to have the value for array and so on. So you use the index addressing. Okay, so this is how especially the displacement addressing with three type of the place displacement addressing is relative addressing. Okay, so from in the PC, it has the PC here, and then you want to make the addition here, and then you will find the operand in the memory. So this one basically for the relative addressing. For the base register addressing, so you have the register. From here, it use the, for the relative addressing, so you use the program counter. But for the base register instruction, it use the registers. Okay, registers, base register, and then address where the operand located in the memory with the add instruction. And then another one is index addressing. So index addressing also use the register index, all right? Use the register called index register, all right? And then we'll do the operation, and then find the operand in the memory. Okay, so this is the displacement addressing with three types of method that commonly used in displacement of addressing, relative, base register, and index. Okay, we have the stack addressing mode. Yeah, before this, we know that some of the method use the PC and some the method use registers. Either they use the base registers or index register. So for the stack addressing mode, actually the operand is implicitly on top of stack. So we know that the stack was in the memory. Okay, so the operand is actually implicit hiding at the top of the stack register. Okay, and then it will refer to the top of stack actually. Okay, for example, you want to do the add here. Pop top. So pop top 2 items from stack and add. Okay, pop top 2 items. So any 2 items from stack and add. Okay, so this is pop of stack register, and then it will refer to the top of stack in the segmentation because it will look into the top of the stack. So that's why the stack addressing mode actually implicitly on top of stack. Okay. All right. So this is the how the topic is all about, to look into how the method of addressing mode, if you have the expression to do, and what kind of instruction format that you can use, all right, in the CPU. And some of it we use the memory to proceed with the operation instruction format. Okay. Okay, so next week we will proceed with the next topic. Right, we try to complete the next topic for next week. That is still under assembly language. I think on Friday we will proceed with chapter assembly format. Okay. We will look into the introduction, assembly language, program format. the data definition. Yeah, we look into that one. And if we can complete this topic, 3 topics for assembly language as soon as possible, then I will provide you with some of the question and you can try to do the solution for that. Okay, so that you have the clear picture on the assembly language. I will share this one. Okay, so this is the next topic that we will look. We will learn, all right? So this one, assembly language, program format, and also the data definition. And also if we still have time, we look into the debug program. Okay, so any questions so far?
No.
Right. So hopefully you can update your attendance. All right. Next week, please be prepared with your group presentation. Hopefully all of you can use the time on Wednesday to present. And then the rest of it, we try to complete all this topic before your final exam. Okay? Any question? If you don't have any question, like you say, all right, we can end our class now. Thank you very much for your time. See you next week. All right?
Okay,
Okay,
thank you,
bye.
Doctor.